Good morning, ma'am. My name is P. Banashri. My nominal role is 22951A 3311. I'm from CSIT A section. My topic is an imperial study of type-related defects in Python projects. Introductions to the study. This study investigates type-related defects in Python project. Type-related defects can lead to significant runtime errors and affect software reliability. Understanding these defects can improve Python development practices. And the background on type related defects are the type related defects occur when variables are used appropriately, inappropriately, according to their data type. These defects can include type mismatches, incorrect type assumptions, and implicit conversions. The impact of these defects can profound, leading to bugs that are hard to trace and which are used inappropriately according to their data type. And these defects can also include the mismatches which are done by the user and the incorrect type assumptions and the implicit conversions which are made. So we are using Python. According to the Python project, here we discuss the importance of Python. Python is one of the most popular programming languages due to its simplicity and versatility. The dynamic typing features of Python can sometimes lead to type related issues, and understanding how these issues manifest in Python projects is crucial for developers. The objectives of study. The primary objective is to identify and analyze the prevalence of type related defects in Python. The study aim to establish a relationship between type related defects and project characteristics. Finally, it seeks to provide recommendations for minimizing such defects in future projects. And the reach methodology of Python project, the study employs a data mining approach to analyze a data set of Python projects. A combination of static code analysis and manual code reviews was used to identify the defects. Statistical techniques were applied to analyze the relationship between the defects and the project features. And the data collection, a wide range of open source Python projects were selected for analysis. And the dataset included various project sizes, domains, and development stages. Each project was analyzed for type related defects using defined criteria. Tools and techniques, static analysis tools such as Pylint and MyPy were utilized to detect type related issues. Manual code reviews provided qualitative insights into the nature of the defects. Data mining techniques were applied to extract patterns and correlations from the data. Types of defects identified. The study characterized type related defects into several types, including type mismatches and incorrect assumptions. Each defect type was analyzed to determine its frequency and impact on code execution. Characterized type related defects into several types are including the mismatches which are done while uh, creating the project or designing the project, and the incorrect assumptions which are made while developing the project. Each defect was analyzed to determine its frequency, and it will impact on the type mismatches, and the incorrect assumptions which are made will impact on the code execution. So the which we made the mismatches and incorrect assumptions should be identified and should be for the code execution. Understanding these categories helps in developing targeted solutions. Frequency of defects. The analysis revealed that type mismatches were the most common type of defect identified. These analyses, which revealed that the type mismatches were the most common type of defect identified. The defect identified is mostly the type mismatches, and a significant number of projects exhibited multiple instances of the same type defect. And these type defects are exhibited multiple times in a significant number of projects. And the frequency of defects varied significantly across different project sizes. Regarding to the project sizes, the frequency of defects were significantly crossed or across different project sizes. Impact on project quality. Type related defects were found to correlate with a decrease in overall project quality. These defects were found to correlate to the decrease of overall project quality to the better execution of the project. And the project with high defect counts experienced increased bugs and reports maintenance challenges. The defects which are made more in the projects will identified as the bug increased reports and will give some warning as the maintenance challenges to the project, and the code will not be executed due to these defects, more defects found in the project. Addressing these defects early in the development process can enhance the software reliability. So addressing the defects before knowing it will develop the process of enhancement of the Python project which we are developing in the software reliability. Case studies of defects. So there are several case studies were conducted to illustrate the impact of type related defects. Each case study provided insights into how defects merged and were resolved. So each case study states that how many defects and what are the defects we found in the project, and then it will resolve how it resolved the defects in the project it will define. And these examples highlight the importance of rigorous type checks during development. So, these case studies which we are providing will take as an examples for the future project and will highlight the importance of rigorous type checks during the development. So it will help to detect the defects in future development project easily by using the case studies, by taking the example of case studies. So project characteristic analyzed. Project characteristic will include the size, complexity, team experience. So the size is important, and the complexity and the team experience is uh, the main role to develop a project successfully. So these factors were analyzed to understand their influence on the prevalence of type related defects. The results can guide developers in managing projects more efficiently. So in managing projects, by the guide, this all results will make him better or make her better to experience the managing of projects to the developers, and it will guide the developers to manage the projects more efficiently due to the size complexity and the team experience. And the factors were analyzed to understand the influence of the prevalence. So these factors will influence the prevalence of type related defects. Statistical analysis results. So statistical techniques revealed significant correlations between the project characteristics and defect prevalence. So the statistical techniques maintain the barrier between the uh, uh, project characteristics and defect prevalence, and the larger products tended to have their a higher number of type related defects. So when we are developing a larger project, it may have more defects by according to the regarding to the small project, and it may have the higher number of type related defects. Team experience also played a crucial role in defect management. Recommendations for developers. Developers should implement stricter type checking and validation during development. Utilizing type hinting and static analysis tools can significantly reduce type related defects. Regular code reviews and pair programming can help catch defects early in the process. So regular code reviews and the pair programming, it will help the developers to find the defects or catch the defects early before it occurs in the process. And utilizing type hints, like type hinting. Type hinting is nothing but when we are executing a code, it will give the statistical analysis tool can significantly, it can reduce the type related defects while we are typing. And the developer should implement the sticker type checking, like whatever sticker type checking and the validation during the development. Limitations of study. The study is implemented to open source Python projects, which may not represent all Python usages. The reliance of static analysis tools may miss some runtime type related issues, and the future research could expand to include a wider range of project types and environments. So, future research directions. Future studies could explore type related defects in other programming languages for comparative analysis. And the research could also investigate the effectiveness of various development practices in reducing defects. So this research in so the project research can also make, if we do the research, could also investigate the effectiveness of various deployment and which make the project to reduce the defects. And longitudinal studies may provide insights into how type related defects evolve over time. Conclusion. This study highlights the significance of type related defects in Python project. Understanding and addressing these defects can lead to improved software quality and reliability. Ongoing research and development practices must focus on minimizing type related issues. Thank you, ma'am.